Hey guys, welcome back to my channel and welcome back to another episode in the saga of the Terex TB85 manlift repair. So, when last we spoke, or when last you heard me speak, I talked about that I thought that I had narrowed the problem down to this board. So for those of you who are just joining me now because you have a problem with the controls on your Terex and it uses this god-awful OEM controls out of Connecticut system with these PC boards. All right, and the reason why I say god-awful is because of what they charge for repair parts. So I'll cut right to the chase. I believe that I think I ended up figuring out that you couldn't get the board anymore, and if you could find the board, it was exorbitantly expensive. And so then that resulted in, well, you could send it to them and they could test the board and upgrade it, and that was exorbitantly expensive. Then I went and found some aftermarket companies, or I should just say repair shops that specialize in industrial controllers. And I did find some that actually know this board and have done repairs on this board and are confident enough that they can tell you that if you send them the board, they'll make sure they send you back a working board. Problem is, those guys wanted like, I don't even remember anymore, but it was like at least $2,000 just to take this board, not give me a new board. I mean, look at this thing. Can you imagine? It's not made of gold. Okay. Anyways, I digress. I'm just getting a little upset still every time I think about how much they are hosing people for charging that much to do simple component level repair on a board like this. Then again, hell, maybe it really is difficult to get this goop that they put on this board to protect it off of here so you can get to the circuitry. I don't know. So for those of you who haven't seen my previous video or videos, what I ended up doing was I ended up opening up the upper control box, finding a rat's nest of bad wiring that had been done in that thing, and some other really scary looking things that were going on, and ended up fixing all of the wiring. I actually only found one actual component that was bad, which was this micro switch. So I replaced this micro switch. This is the retract and the extend and retract for the boom. That's what this control is. Reason why I have this out of the machine right now is because I am going to bench test this Superflex 4 board. So this is the OEM Controls SF4 board. It's the Superflex controls. This is actually one of the two boards that's down in the lower control unit, the lower control box. The other board is a relay board. This board right here accepts incoming commands from the upper control station and amplifies those inputs. Those inputs come in on this plug right here, amplifies those inputs through these semiconductors and outputs DC voltage on these pins right here of this plug. So it's pretty straightforward. Input, output. There are 3 status lights here that tell you if this light in the middle, which is CPU, is flashing, it means literally on this, it tells you that if the CPU light is flashing, supposedly the SF4 is okay. In other words, they're trying to say that if this light's flashing, there's nothing wrong with this board. Okay. There is also an input light right here that when you activate the controls, if this board senses an input from these devices here, which are called digi sensors, these doohickeys right here, okay, if this board senses inputs from this input light lights. And if it's sending an output signal to actuate the solenoid controlled hydraulic valves, then this output light will flash as it's generating an output. So why do I think this board is the problem? Well, the reason why I think this board is the problem is because when I work the controls up in the aerial lift, this input light flashes. And the CPU light flashes to indicate that that's running okay. And the output light flashes. So according to the self-diagnostics that this board is able to do, or the self-monitoring that this board is able to do, it thinks that it's sending out the signal to those solenoid valves. Okay? The problem is it doesn't work. So after fixing this and fixing all the wiring issues that I could see, I got to a point where I can drive the machine, I can raise and lower the boom, I can extend and retract the boom, but I either can't rotate right or rotate left at all, or if I do, it's very, very slow. My first thought was, well, maybe I have bad digi sensors on that other joystick. However, when I actuate that joystick, even though it doesn't turn the machine or it doesn't swing the machine left and right, it still generates an input signal to make this light flash and an output signal. So that's why I figured maybe there's something wrong in this output section over here. So these semiconductors right here are obviously going to be the drivers that are going to create the 12 volts that goes to those solenoids. I should say variable voltage going to the solenoids. Maximum would be 12 volts because that's what this whole system runs on, the 12 volt battery. So if you send the full 12 volts to it, it's gonna open that valve up to max, and it's gonna swing at max speed. So when you're on the ground, at the ground controls, there are toggle switches that allow you to control many of the features from the ground. And all those toggle switches do is bypass this and send 12 volts directly to those solenoids. And guess what? When I use those toggle switches, everything works. So I know it has nothing to do with the hydraulic valves. It has nothing to do with the hydraulic controlled solenoid valves. It's got to be something else going on here. So I was able to learn quite a bit about this system just by looking at this cover that I took off with the sticker on it here. There's the DigiSense right there, but it actually also shows you that as an alternative to having a DigiSensor, you can just have a switch that switches 12 volts. So on the DigiSensor, we got 12 volts that comes into the DigiSensor, and then depending on where it's rotated, it will send 12 volts out. What's kind of wild about the system, though, is that the system somehow knows which way the DigiSensor is being rotated, so it can tell you which direction you want to go. In other words, we've got, this is the, again, this is the boom control, extend or retract. Well, when I flip this, no matter which direction I flip it, first thing it does is it shuts this micro switch and puts that DigiSensor in series with the circuit. But when I push it one way, we want the boom to retract, and when we push it the other way, we want the boom to extend. And the only thing that's happening physically when we do this is we're changing the direction of rotation of this thing. So one of the problems I had with wanting to be able to bench test this is that I didn't have any of these plugs. So what I ended up doing was I had some plugs from some old appliances, and I actually just cut them and sliced them up and made little test plugs so that I could plug into these larger plugs. So I can move this around depending on where I want to, which of these I want to hook up to. But of course, they've got this crazy thing where you've got all these different, so like this is a 4 pin one that I kind of made up here, but I might have to cut that into a 2-pin one to give me more flexibility here, because right now, because it's a 4 pin, it really only wants to plug in in one location here, because you see there's 4 square holes here, but all of these other locations have at least one, if not more, holes that are not square and have a round and a flat, so that you can't inadvertently plug something in the wrong way. I'll have to forgive that noise. My my old Tektronix 2445 scope here has a cooling fan inside that is noisy. So I know that this plug up here is the power input, and I know it runs on 12 volts. So that was pretty easy to figure that out. It actually clearly tells me BT5 is power, and then there's a pin out here, and it tells me that 1 and 3 are positive, and 2 and 4 are negative. And why are there 2? Well, because in different applications maybe they do it a different way, but those pins are common to each other. So the 2 positive pins, I already checked with an ohm meter, they're connected. So it doesn't matter which of those I use. I've actually already got it hooked up. I've got my 12 volt regulated power supply right here. So if I turn this on, I've got nothing else hooked up except the power. But when I turn it on, you'll notice the little LED for CPU is flashing. And again, what this tells me is, this tells me that this thing, the CPU is running. According to what it says on the cover, it means this whole board is good if this is flashing, but I have my doubts. We're going to see. We're going to do some tests and figure that out. But what's important to know is, if you power this up and this light stays on solid, that means you've got a fault on this board. Your Superflex 4 PC board is bad. Now, it could mean you have problems elsewhere too, but for starters, you've got a bad board. At least that's what the manual for the board from OEM Controls actually implies. If this light doesn't light at all, just seems like it's completely dead, then you have to go verify and make sure you have your proper 12 volts coming in here. So it could be a power problem somewhere else in the system. But if you've got 12 volts coming in on here, this should flash, even with nothing else hooked up. I mean, right now I've got these plugs in here. There's nothing hooked to any of these wires. Nothing hooked to the output, nothing hooked to the input. These pages I have copied right here are from a PDF download of the service manual for this Terex TB85. All you're going to do is a Google search, service manual TB85, Terex TB85, and you'll be able to find it just like I did. But if you're not good at reading wiring diagrams and schematics, good luck, because this can be pretty confusing. So over here is my bank of solenoid controlled hydraulic valves. These are the outputs. This right here is the control box, okay, which contains the board that I'm testing here and other stuff, right, and other wiring. But all that this is explaining to you is that these are the wires coming out of the box for the different functions and going over to the valves here. So right here we've got turret, rotate counterclockwise, and then skip one, plastic ground, we've got turret, rotate clockwise. Those are the two functions that are not working for me. I was able to determine that these 2 semiconductors right here are the 2 channels responsible for moving the turret clockwise and counterclockwise. So I put little black dots on them. So the first thing I want to do is I want to determine exactly which pins are the input pins for this control right here, which extends and retracts the boom. Reason being is because I know this works when I have it in the machine. So that tells me that this digi-sensor must be okay, and that part of this circuit board that's responsible for generating an output over here must be okay. So if I hook this up to the proper input and look at the proper output with the scope, I should be able to see what the normal waveform should look like coming out of this thing when you move the joystick. That will be my reference, and then I can compare that as I move this digi-sensor to other channels and see whether or not when I get to these bad, or these 2 channels that seem to be giving me the problem, whether or not they are indeed bad. If I'm able to make this digi-sensor work on all of the inputs and generate all of the proper outputs, that tells me that my problem is more likely an actual problem with the digi-sensors in that other joystick, that even though they seem to be sending out something to cause an input, they're not sending out enough. Does that make sense? Oh, I already got to make a correction of myself. So I inadvertently mentioned that it looked like you could either use a switch or a digi-sense on any of these inputs. Incorrect. It's clear now that certain ones of these inputs are marked like that one, pin 3 is SW10, pin 4 is SW11. So those could be just switched. But the ones that say DS4 or DS anything or switch means that those inputs apparently could take either or a switch or a DigiSense input, and it's probably programming on the board level that actually decides what it can or cannot accept. So I could probably assume that my DigiSenses aren't going to be hooked up to any of these ones that say switch only. It's got to be these ones that say like DS4, DS2, DS5, DS3, DS1. The top one here, pin 1, is DS6, but I know that there's nothing running to pin 1 on the plug. So when I go look at the wiring harness in the machine, pins 1 and 7 here are not used at all. So 1 for DS6 is not used, and 7 for DS5 is not used. So there's really only 4 channels that use DigiSense inputs. DS1, DS2, DS3, and DS4. So it looks like DigiSense 4 is the first one going from top to bottom. DigiSense 4 is the first one that appears to be used in this machine, which is pin 5. And so that's going to be my makeshift plug here. It's going to be this wire here. So I already stripped this. So an interesting diagnostic here. It says that if the input LED is on solid, then check the wiring for shorts of positive on DigiSense inputs, because obviously if it's a switch, when you close the switch, it's going to be 12 volts on there. So those inputs for switches are designed to be able to accept a full 12 volt input, as opposed to the DigiSense ones. If they see full 12 volts, this will not flash on the input, it will stay lit. So let's see. So I've turned it back on now, and we see that light is flashing for the CPU. And if I put this wire now, this input, if I short it to 12 volts, there we go. That light stays on. So now I should be able to run this wire to my DigiSense, and we should be able to actually get this light to flash. And I know that the inputs have to come off of the black wires on the DigiSense, because the red wire is where the 12 volt goes in. So I've got to send 12 volts to here. Okay, now I've got 12 volts going in here. Nothing's happening yet, because as soon as I start moving this, the microswitch will close. That'll energize the DigiSensor, and the DigiSensor should start sending a signal in here and make this flash. There we go. Interesting. Why did it stop? Worked for a few seconds and then stopped. So might have a bad connection here. So you'll notice that when I first energized it, it was flashing input, CPU was still running, no output, but then it started to generate an output. There seems to be a delay. I think that's normal. Oh no, that's actually, now that's doing it quickly. Interesting. Try going in the other direction. See, now that seems normal. Also, there are LEDs actually on the DigiSensor itself. That one lights when I go in this direction, and the other one lights when I go in that direction. Alright, now I have to figure out which one of these output pins I'm going to scope so I can see what kind of a waveform's coming out of here. Alright, so what I did was, all of the wires in this thing, almost 90% of them are white. But then each individual wire has a tiny little number stenciled right on it, so you could tell the wires apart. So what I did was, I wanted to figure out which of these pins on this plug corresponds to which joystick control or digi-sensor. So what I did was I went out there, and the plug is numbered, the pins on the plug there's 12 of them, 1 through 12. And then I looked at every single wire going into that plug and wrote down the number on the actual wire. I did notice that 1 and 7 aren't used. So we've got 2, 4, 6, 8, total of 10 wires, pins 2 through 12. Most of the wires have a 3-digit number, except for number 8 has 54. And then there's a wire just hanging that's in the bundle, so it's wire tied to the rest of these wires. So it's part of that wiring harness, but instead of being in the actual plastic connector, it's just floating in space. So I'm pretty sure the factory wouldn't leave it that way. So for some reason, somebody took that wire out of one of these other one of these spaces, and only 1 and 7 are open. So I'm going to see if I can figure out what that is, but I think I already tried to look that up and couldn't figure out what it was. My life would be a lot easier if the wiring diagrams here were, if these PDF files weren't so blurry. If you try and blow them up, they become even more illegible. But if I look at this diagram for the aerial station, they do a pretty good job of blocking out each one of these controls up on the aerial station. So for instance, this dotted line right here going around this whole area right here is all for the steering controls, the steering left and right and the forward and reverse. And then this next one down says lift controller, so this is to make the boom go up and down. And then this next one is the rotate controller. And then the next one down from that is the extension controller. So that makes the boom extend and retract. And then this right down here is for the platform tilt. So the platform tilt is just a switch. It's not a digi-sensor. Whereas you can see this one right above it here. This is this right here is this joystick I have on the bench right now. And you can actually see in the block they're showing there's the micro switch, and this is the digi-sensor. And they're showing the black wire here coming out, and they're calling that an output. And then they're got the red/black wire right here. That is the 12-volt supply going in. So you'll notice the output is 108. Wire number 108. If I come over to this sheet, which is more like a interconnection diagram between all of the different boxes. You can see over here we have the aerial control, and then we have the ground control. And what they've done over here in this block is they're showing you how all of these wires are numbered depending on what job they do. So if we zoom in on this and we look, and we come down and look for wire number 108, it's right there. It's boom, extend, retract, output. So now I know that wire 108 is the boom, extend, retract, which is pin 6. So now I know pin 6 down here is boom, extend, retract. So I come back over to this diagram and I look at pin 6 and I see it is DS2. So now I know pin 6 DS2, digi-sensor 2 input, is for boom, extend, retract. So I'm just going to take a few minutes off camera and label all of these. Alright, so I know that there are 6 possible inputs that can accept DigiSense inputs, DS1 through 6. Turns out the machine only uses 4 of these. It uses DS1 for forward and reverse. Steering is actually simple switch inputs. There are 2 other pins that when they get inputs of full 12 volts, they'll cause the machine to steer left or steer right. DS2 is the boom extension and retract. DS3 is the lift control, the boom up and down. And DS4 is the rotate control, the one that's not working. DS5 is on pin 7 and DS6 is on pin 1. Those are both the unused pins. That's interesting to me because if I end up determining that the problem is actually on this board, maybe I can switch the wiring over to use these 2 channels or one of these 2 channels that's being unused to sub for the one that's not working. So it's interesting to me that on the output here, we only seem to have outputs 1 through 4. Now there's 1 through 4A and 1 through 4B, and that's because each one of those digi-sensors, depending on which direction you're moving the lever, is going to give you a different output. In other words, I'd venture to guess that DS1, digi-sensor 1 input, will actually cause an output to appear on either PWM 1A or 1B, depending on which direction the lever is moved. And the same thing for the other ones. So, remember there's those 2 extra ones, 5 and 6, that aren't used. How come they're not shown here? I'm wondering whether or not that's what aux1 and aux2 is. Although that doesn't make sense actually, because there should be 2 output pins available for each single digi-sensor input. Because remember, depending on which way the digi-sensor is rotated, it gives you a different output. So much for my idea of trying to use those unused circuits as possible replacements for a dead circuit or an ailing circuit, because I don't have the outputs over here apparently. There's probably a way to tie any one of these DigiSense inputs to activate any one of these outputs, but it's probably a programming. It's probably done through programming of the board, which I can't do. Now, I don't know exactly which one of these outputs corresponds to what operation it does. To do that, I could either go back out to the machine and look at the wire numbers on all of the wires going into this plug, just like I did with the other, the input plug, and figure out which wire goes where, and then tie that function to the particular output. But I think it's a pretty safe assumption that DS1 corresponds to PWM1A and 1B. So if that's the case, I am currently hooked up to pin 5, which is DS4. So I want to monitor PWM 4A and 4B, which is going to be pin 3 and pin 9, which is going to be these 2 wires right here. These first 4 pins in this plug aren't used because 2 of them are marked NC for not connected, and the other 2 are those aux1 and aux2. Alright, so now let's turn this on. Okay, CPU light is flashing. I'm going to just double check and make sure that this is still hooked up correctly. Yep, okay, so that's showing input and output. So now I'm going to monitor one of those 2. I don't know which one this is, A or B. And I'm going to push this control and see if anything happens. Alright, nothing happening on the scope. Let's push it the other way. There we go. Nice. Nice waveform. I'll give you a close-up of that. So we get a pretty good waveform there. So it's kind of hard to see it. Let me see if I can get this to trigger. Okay, I had to switch my trigger source to channel 1, which I'm on. So now that it's triggered, the waveform doesn't move so much. We can see it better. So what we got basically a square wave, and it's kind of hard to see, but as I push the control further, that pulse width is actually widening. And the effect would be to actually send more power to the solenoid that is actuating that hydraulic valve. So again, if I push the joystick back, nothing happens. If I push it forward, I get the waveform. So if I switch to the other wire, so if that's A, let's just assume that's A for a moment. I'm going to switch my scope to actually be on the other pin, which would be B. Now when I push back, I should get the waveform. And I do. And it's an identical waveform. And again, if I push forward now, I get nothing because that would be the other channel. So if I push the joystick in one direction, it generates the waveform on A, and if I push it the other direction, it generates the waveform on B. And I have my scope set at 2 volts per division in case you're curious, which is giving me basically each one of these divisions is 2 volts. So when I flip this over, the pulse height is 2, 4, 6, 8, 10, just under 12 volts. So what I have to do next is I need to change the configuration here on the input so that I can now actuate one of the other DS inputs and check its output. And I'm going to just systematically go through and check every single one of them. But it's interesting to note that DS4 is the rotation control. So according to what I'm seeing here, it looks like this board is working correctly. So what the heck is going on? All right, now I've got the my good DigiSensor control input into DS2, because I know DS2 is boom, retract, and extend, and I know that's working correctly. So I want to see what that waveform looks like. See if it looks identical to the one we just saw. So I'm looking at either 2A or 2B output. So let's see. You know, there we go. It's the same waveform, same amplitude and everything. And if I push back, I get nothing. But if I switch to, assuming that was 2A, we'll switch to the other one, 2B. Nothing when I push back. Nothing when I push forward. What is going on here? Oh, well, so this is interesting. When I use DS2, I can get it only to work in one direction. So in other words, I can get output on this wire or this pin. But then when I push this back, I would expect to get an output on the other wire, and I'm not getting anything. But I'm also noticing my output LED doesn't flash. It's getting the input, and it's not sending an output. So for some reason the board is choosing not to send an output. Now it might be because I have this board out of the machine. Maybe there's some sort of a limit switch or something that is not, that tells the board if the boom is fully extended or fully retracted already. All right, let's try DS3. Okay, I'm getting, interesting. It says it's outputting, but I'm not getting anything. I am on DS3, right? I gotta double check my wiring here. Yeah, I was on the wrong input pin. All right, should work now. Let's see. All right, so that one's acting the same way. It's only giving me an output in one state. I push the joystick in this direction, the output LED doesn't flash. In this direction it does, and it does give me the waveform. So, I now have my DigiSensor on input DS1, pin 12. And this one, it's monitoring the input and not sending an output no matter which direction I put the joystick in, which is interesting. So DS1 is the only channel that's not giving me output no matter which input I give it. Now I thought that I determined DS1 is the forward reverse. Then again, that could be something as simple as, again, not having this in the machine. Maybe this thing actually senses whether or not the engine's even running. Well, I just went back out to the machine to verify that pins 3 and 9 output here are in fact for the rotate left and right of the turret. The problem I'm having, turret not rotating. So this board, when it gets a signal from a DigiSense, it tends to be working. The reason why I wanted to verify this is because clearly I can get an output that looks good to me on the scope here from both of these pins when I hook a DigiSensor up to the proper input here. Now this is the DigiSensor for the boom retract, extend and retract, right? So I'm using this one because I know this is a good one. So now, since the board seems to be fine, now I have to wonder whether or not there's something wrong with the DigiSensors in that other joystick. So I just pulled the other joystick. So this is the joystick assembly for rotation and elevation. Elevation does work. It's rotation that doesn't work. So one of these DigiSensors is for rotation and one's for elevation. I actually don't remember which is which. Not that it matters because I'm going to test both. So again, we got micro switches. Now the interesting thing to me is when I was diagnosing this in an earlier video, I was able to see that the input and output lights would flash when I would actuate this joystick in the machine, but the machine wouldn't move. The turret wouldn't rotate, which made no sense to me. But maybe there's something wrong with these DigiSenses that allows them to generate just enough signal to actuate this board, but not enough signal to tell. Something's weird. That just doesn't make sense. But at this point, I've got nothing else to go on, so I might as well give it a shot. You can see the heat shrink tubing and everything. This is all the damaged wiring I had to fix on this thing, so this was kind of a nightmare. Plus, I am curious to see whether or not these LEDs will light the way that the ones do in the other one. So give me a few minutes to hook this up. Okay, so I'm hooked up to this screw right here. So I got 12 volts going into here through this micro switch, goes through this wire, and heads over to this DigiSensor here. So we're going to be testing this DigiSensor first, which is activated and rotated when I move the joystick this way and that way. There it is. Good waveform. I turned my intensity down because I had my scope on for a while there. That looks identical to the waveform I was getting with the other one. Let's see, do the lights come on? Yeah, they do. Yeah. All right, let's see if we got output on the other channel. Yep, I do. Okay, but maybe that's the one for lift. Let's test the other one now. Okay, so now that's going to be this one. Okay. I'm getting my 3 lights. Let's see if the output's in the other direction. There it is. Same waveform. And let's see, so that's if I push away from me, I get the waveform. So if I change to the other pin, if I pull towards me, I get the waveform. This is working correctly. The board is working correctly. What the heck's going on with this thing? So my next thought was, well, okay, maybe there's something wrong with the wiring between the ground control box and the aerial control. In other words, these connections I'm making right here, these wires go through a series of connectors down through the whole long boom all the way down into the control box to here. So at any point there could be a break in the wire. My problem with that theory is if I had a broken wire, open circuit, then when I move these levers, I shouldn't be getting these lights down in the control box. And I was, even though the machine wasn't moving. And then I know what you're thinking. Well, then obviously, though, it's got to be then something after this board and the output. The problem is I checked the wiring. It goes from here, it goes right over to the toggle switches for ground control that lets you basically override the output of this and just send full 12 volts to the thing, which do work, over to the solenoids. And the solenoids are all working because, again, you know, activate those toggle switches, send full 12 volts, and they do what they're supposed to do. So what I'm going to do next is I'm going to put this back into the machine, and I'm going to hook up all of the plugs except the input plug. And then I'm just going to use one of these while I'm standing there at the machine, temporarily wired into this, to see whether or not I can actually make the thing move. If I can, then it means I do have a wiring issue, and that even though this thing is sending a signal and making these lights light, that the wiring is somehow causing some kind of a weird issue. And so it could be a wiring issue, or it could also be a sensor that I'm just not exactly aware of right now. In other words, there could be something that prohibits this thing from sending output, even though it's flashing output and saying it's sending it. No, wait a minute. Yeah, so this is weird. All right, guys, so I'm going to call this video a wrap. It was probably already too long, but I think I'm done with my bench testing, and I'm satisfied that this board is working correctly. I'm pretty darn sure it is. And I'm also pretty darn sure my digi sensors are good in my two joystick controls here. All right, till next time, take care.